Find a vector equation and parametric equations for the line segment that joins P and Q. So we have 2 points, point P, XYZ, 1, negative 1, 4, point Q, XYZ, 4, 8, 1. So we have 2 points, point P and then point Q. You don't really need three-dimensional graph, just put it on your paper, point P and point Q, you connect them. So this is the location of P, this is the location of Q. So what we are trying to do is we want to parameterize this line segment, and then we want to let T equals to time, and this T is a parameter. So when T equals to 0, we are at point P. When T is equals to 1, we are at point Q. So that means it takes 1 second to travel from point P to point Q. So we have two initial vectors. The first initial vectors is r of 0. So we are at 1, negative 1, 4. So this is the position vector at P. And then r of 1. This is 4, 8, 1. That is the position vector at Q. So what we are trying to do next is we are trying to draw a vector equation for the line segment that joins the tip of the initial vector and the tip of R1. So let's write this down. It's too many words to take, right? So we want to write a vector equation for the line segment that joins the tip of R0 and the tip of R1. What is that vector? So that vector is R of T. So R of T, which is equals to 1 minus T, and then R of 0 plus T, and then R1. This is true every single time. This is true in every single problem, but for the R0 and R1, that is different in every single problem. So this is, oh, by the way, for this, you will have to write this down. Every time you solve this type of problem, you have to start with this. And then 1 minus T, so we have 1 minus T, and then the initial, the position vector at P is 1, negative 1, 4, and then you add T, and then 4, 8, 1. So everything followed by that is super easy. That works just like a distribution. So we have vector RT that is equals to, you distribute the 1 minus T, so you have 1 minus T, comma, negative 1 plus T, comma, distribute that to the 4, you have 4 minus 4T. And then you plus 4T, and then 8T, and then a T. And then what is that equal to? So all you have to do is you just have to add them like that. So 1 minus T plus 4T. So overall, the vector R of T, that is equals to 1 minus T plus 4T. So negative 1 plus 4 is positive 3. Then we have 1 plus 3T. And then also here, 1 plus 8 is 9. Then we have negative 1 plus 9T. And then negative 4 plus 1 is negative 3. And then we have a comma, 4 minus 3T. And then what is this? This is our vector function where T is between 0 and 1. So T is between 0 and 1. And then let's box that because this is our answer. So this is our vector function. Move the box. So this is our vector function. What else do we need? We need to know that when T is equals to 0, so when T is equals to 0, we are at P, we are at point P, and then as T approaches to 1 second, we travel from point P to point Q. Travel from point P to point Q. And then how about the parametric equation? So for the parametric equation, we have three components, x, y, and z. Then all you have to take is we take that straight from the vector function. So let's use a different color. They are also asking for parametric equation, right? So we find a vector function, which is in the blue box, and then the parametric equation, all right, parametric equation. We have three components, x, y, and z components. So all we have to do is x is equals to that 1 plus 3t. So this is a 1 plus 3t. And then y is equals to here, negative 1 plus 9t, negative 1 plus 9t. And z is equals to right over there, 4 minus 3t. So we have a 4 minus 3t. And then this is also the let's don't box that parametric equation. So we have three equations right over here. That is our answers as well. So that is also the end of this video. If you like the way I explain this type of problem, give this video a thumbs up. If this is something what you want to see in the future, subscribe to my channel. Trust me, it is worthwhile coming back to with more math content. As always, I will meet you all in the next video. Take care.